Earth, rotating in space, 22,000 miles away. The perspective is one that shows us how interdependent the natural systems that support all life on the planet really are. Everything actually is connected to everything else. The sun, prevailing winds, and climate conditions compel the movement of sea surface ice and continental snow masses. Vegetation grows and declines as these systems advance and retreat. The temperatures of the great ocean's currents both drive and are driven by these global weather patterns. The Earth is breathing and in balance. The Earth is alive. But a threat to this delicate balance is now growing in the Earth's atmosphere. It is now growing less permeable as a result of air emissions from a variety of human activities powered by the combustion of fossil fuels. Although the sun's light still penetrates, its reflected heat from the Earth's surface becomes trapped, raising the ambient temperature of the globe. The majority of scientists worldwide agree that global warming is now taking place, and most agree that it could have potentially serious consequences for all life on the planet. Human activities in our largest population centers, the cities, account for the vast majority of these global greenhouse gas emissions. As the world becomes more urbanized, this phenomenon grows. In the United States, the situation is especially evident. Today, 80% of our population lives in urban areas, and more than half live within the 25 largest cities. American cities and towns now account for over 80% of our national energy use, and urban land use development affects 70% of that consumption. As our urban centers expand at the edges, low-density residential, commercial, and industrial developments claim previous agricultural, forest, and open lands. And from a resource use standpoint, this development consumes 85% more energy, 70 times more water, 50 times more lumber, and 40 times more land than higher density developments of equal size. To sustain the diversity of life on the planet, we must change the way we relate to our shared environment and the way it relates to us. Change the way we design, develop, and manage our cities and the way we conduct life in them. This presentation provides a model for that transformation. A shift from communities that consume and degrade our natural resources to communities that consciously sustain them and improve the quality of all life on the planet. 5 overriding principles guide this design. 1. The need to utilize all potential sources of energy while controlling all energy-related pollutants. 2. The need to maximize the benefits of natural systems such as wind and water flows, sunshine, precipitation, and the absorbency of land and vegetation. 3. The cooperation and involvement of the community in the everyday management of resources. 4. The need to allow higher concentration of mixed-use development across our cities. 5. The establishment of equal opportunities for all residents to affordable housing, social services, and access to efficient transportation. The subject for this design is the Greater San Diego-Tijuana Binational Metropolitan Region, chosen to emphasize the importance of a region-wide air and watershed basin approach to sustainable development, regardless of jurisdictional borders. Today, the region supports a population of approximately 4.3 million people. They reside in the city of San Diego, the municipality of Tijuana, 17 additional incorporated cities and unincorporated areas of San Diego County, as well as the Mexican cities of Tecate and Rosarito. Like most urban communities, this binational metropolitan region is growing at an ever-accelerating rate, with the current population expected to soar to 8 million by 2030 and more than 15 million by 2103. Under a business-as-usual approach, this growth will far exceed the current infrastructure planning, financing, and land available for development. And much of this development will be at the expense of ecologically sensitive land, animal habitat, and the remaining farmland. Other essential resources such as imported water and energy, the extremely limited stock of affordable housing, and air quality will also be heavily stressed. We now venture into an alternative, sustainable future for the region. A future that accommodates projected population and economic growth without degrading the natural environment. In our design for the San Diego-Tijuana metropolitan region, there are 4 urban zones centered on or near Escondido, Sorrento Mesa, downtown San Diego, and downtown Tijuana. Each of these zones contains a hierarchy of primary and secondary cities, surrounded by clusters of smaller villages and their neighborhood communities. We'll focus on one of these urban zones, located on the international border. Approximately 15 miles in diameter, the zone's primary cities accommodate 750,000 to 1 million residents in densities of 122 to 162 units per acre. Secondary cities accommodate 1/3 fewer residents. Villages are approximately 2.5 miles in diameter and accommodate 40,000 to 65,000 residents at densities ranging from 12 to 75 units per acre. The highest population densities are in the city and village centers and along transit corridors that radiate from them. These areas support a diverse mixture of affordable housing, retail and business establishments, employment and educational centers, and cultural and recreational facilities. They also serve as the hubs for the regional transportation system. Surrounding each village is a set of 6 to 8 neighborhood communities, ranging in size from 250 to 310 acres, and accommodating 6,000 to 11,000 residents. Once again, the highest residential densities are found at the neighborhood center with 50 units per acre. These highly walkable neighborhood centers offer easy access to elementary school, shopping, and religious institutions, and civic and office buildings. In the outer edge of the neighborhoods, residential densities taper off to only 12 units per acre. But a sense of place, engendered by homes of the past and historic districts, remains. Blended wing and vertical takeoff and landing aircraft, marine hovercraft, and high-speed magnetic levitation rail provide the principal means of travel to and from the region. This same rail line also connects the primary city centers within the region, as does a network of express flex trolleys connect the primary and secondary cities across the region. Traveling at speeds of up to 50 miles per hour, these computer-guided trolleys move along dedicated guideways, serving stations 3 to 3.7 miles apart in 5 to 10-minute intervals. Providing service between the cities and their outlying villages is a local express version of the same trolley system, although operating at lower speeds and serving stations spaced every 1 mile apart. The primary transit service between cities and their immediate villages and neighborhood centers is a 3-tiered system comprised of a city-to-village tramway, a village-to-neighborhood feeder line, and a network of inter-neighborhood shuttles. Together, all of these fuel cell-powered electric vehicles quickly and conveniently move residents across the region, emitting only water vapor to the atmosphere. Complementing this public transit system is a private mobility vehicle, or PMV system. Ranging in size from 2 to 10 passengers, these fuel cell-powered, computer-driven vehicles provide point-to-point transportation on demand from a centrally housed and maintained fleet. Fully automated PMVs enable passengers to set the destination and then relax or focus on other matters while the vehicle propels itself along sensor-laden guideways. Also available are dual-mode PMVs that allow passengers to take an active role in the process and to travel off of the guideways to remote locations. Most commercial enterprises also use a modified version of the dual-mode vehicle. This combination of public transit and PMV systems provide residents choice, convenience, and emission-free mobility, and effectively replaces the personal and commercial vehicles of the 21st century.